The James Webb Telescope has already uncovered secrets that could rewrite cosmology, and the number one finding is something almost nobody expects. Stay tuned to the end for the mind-blowing finale. Imagine peering back over 13 billion years to witness a galaxy that existed when the universe was less than 5% of its current age. GNZ11, first glimpsed by earlier telescopes, has now been re-examined with JWST's unprecedented infrared sensitivity, revealing a surprisingly mature structure, bright star-forming regions, and a mass comparable to the Milky Way. Researchers estimate its stellar population is older than expected, suggesting that massive galaxies formed much faster than traditional models predict. This challenges our timelines for early galaxy assembly and hints at hidden processes that accelerated growth in the infant cosmos. Up next, number 9 uncovers a hidden chemistry in a newborn star that could rewrite planetary formation theories.
Surprisingly, JWST detected clear signatures of water vapor enveloping the temperate super-Earth K218b, a world located about 124 light-years away. Using the NIRSpec instrument, scientists identified absorption lines that match water molecules, indicating a potentially habitable environment despite the planet's high gravity. While clouds may obscure the surface, the presence of water in the atmosphere suggests that such planets could retain volatiles longer than previously thought. This finding fuels optimism that other nearby exoplanets might host similar conditions, expanding the search for life beyond our solar system. Coming up, number 8 presents the first direct image of a planet still in the act of forming, offering a rare glimpse into planetary birth.
Astronomers captured the first direct image of a planet still coalescing within its natal disk, observed around the young star PDS-70. JWST's mid-infrared camera revealed a glowing protoplanet surrounded by a thick envelope of dust and gas, allowing researchers to estimate its mass at roughly 5 times that of Jupiter. The detailed view shows accretion streams feeding the planet, confirming theories about how giant planets gather material from their surroundings. By watching the process in real time, scientists can refine models of planetary evolution and assess how common such formation pathways might be across the galaxy. Next, number 7 exposes hidden carbon dioxide chemistry in the atmosphere of a nearby super-Earth, shedding light on greenhouse dynamics.
Hidden within the faint infrared spectrum of LHS 3844b, JWST identified distinct absorption features consistent with carbon dioxide, marking the first robust detection of this greenhouse gas on a rocky exoplanet. The planet, orbiting a red dwarf merely 48 light-years away, experiences scorching surface temperatures, yet the presence of CO2 hints at complex atmospheric chemistry possibly driven by volcanic outgassing. Researchers estimate the atmospheric pressure could be a few times that of Earth's, although exact values remain uncertain. This discovery opens a new avenue for assessing planetary habitability and climate evolution beyond our solar system. Moving forward, number 6 delves into the earliest star-forming regions, revealing how the first stellar nurseries ignited the cosmic dawn.
Remarkably, JWST has pinpointed clusters of primordial stars forming just 300 million years after the Big Bang, a period previously thought too early for such activity. Infrared observations uncovered compact, bright knots embedded in dense gas clouds, indicating rapid collapse and ignition of massive stars. Estimates suggest these early stars were dozens of times heavier than our Sun, producing copious ultraviolet radiation that likely contributed to reionizing the universe. By mapping these regions, astronomers can trace the timeline of the first light and better understand how early galaxies acquired their brightness. Up next, number 5 showcases the cosmic web in unprecedented detail, stitching together the scaffolding of the universe.
In the vastness between galaxies, JWST has rendered the cosmic web, a filamentary network of dark matter and gas, with clarity never before achieved. By targeting faint hydrogen emission along intergalactic filaments, the telescope revealed how matter streams converge to feed growing galaxy clusters. These observations suggest that the web's density variations influence galaxy formation rates, providing a tangible link between large-scale structure and local star birth activity. The detailed mapping also offers clues about the distribution of elusive dark matter, as its gravitational pull shapes the filaments. Soon, we'll explore number 4, which uncovers a massive black hole that existed when the universe was still in its infancy.
Unexpectedly, JWST identified a supermassive black hole weighing nearly 1 billion solar masses residing in a galaxy less than 700 million years old. The object, observed through its intense infrared glow and surrounding accretion disk, challenges conventional growth models that struggle to explain such rapid mass accumulation. Some theories propose direct collapse of massive gas clouds or early mergers as possible pathways, but the exact mechanism remains under investigation. This discovery forces astrophysicists to rethink the timeline of black hole evolution and its impact on early galaxy formation. Coming up, number 3 captures a spectacular galaxy collision at a redshift of 6, providing a window into violent cosmic interactions.
Finally, JWST recorded a dramatic merger between two massive galaxies when the universe was only about 1 billion years old. The collision, visible through distorted spiral arms and tidal tails, released bursts of star formation, igniting thousands of new stars within a few million years. Spectroscopic data indicate enriched heavy elements, suggesting that previous generations of stars had already seeded the interstellar medium. This event illustrates that complex, large-scale structures were already interacting violently far earlier than many models predicted. Up next, number 2 reveals how the true sizes of the universe's first galaxies have been reassessed, reshaping our perception of early cosmic architecture.
One of JWST's most striking revelations is that the earliest galaxies are significantly larger and more massive than earlier telescopes indicated. By resolving faint outer regions with its high-resolution infrared imaging, the telescope measured diameters up to 10 times greater than prior estimates, suggesting that galaxy assembly proceeded faster and on larger scales. Researchers estimate stellar masses approaching a few hundred billion suns, implying efficient gas accretion and early starburst activity. This challenges the notion that primordial galaxies were tiny, dim objects, and it hints that the cosmic landscape was already richly textured shortly after the Big Bang. Next, we arrive at the finale, number 1, uncovering an unexpected abundance of complex organic molecules that could reshape our understanding of life's building blocks.
At the pinnacle of JWST's discoveries lies the detection of a surprisingly rich inventory of complex organic molecules, such as methanol, ethanol, and even precursors to amino acids, within distant star-forming regions. The telescope's spectrograph identified distinct absorption features that match laboratory spectra of these compounds, indicating that the chemistry needed for life's building blocks is already widespread in the early universe. Estimates suggest that such molecules may be present in up to 20% of observed nebulae, far exceeding earlier expectations. This finding implies that the raw ingredients for life could have been seeded across the cosmos long before planets like Earth formed, opening new avenues for astrobiology and the search for extraterrestrial life.
We've traveled from the faint glow of the earliest galaxies to the rich chemistry of distant worlds, illustrating just how far the James Webb Telescope is pushing the boundaries of what we know. If you enjoyed this countdown and want to keep exploring the universe's most astonishing discoveries, hit subscribe so you never miss a future list that expands our cosmic perspective. Which finding left you most awestruck? Share your thoughts below, and if this video sparked your curiosity, give it a like to help more viewers join the journey. Thank you for watching, and see you in the next exploration.